G'day, I'm Glenn Morris from the Smart Energy Lab. And today, it's all about lithium-ion batteries, but not the usual residential batteries. These are transportable batteries, RV batteries. Now, I've got a few examples here from a company called Discover. Now, this is their Lithium Blue. Now, it's a range of lithium-ion batteries designed for caravans and RV markets. It's got a handle, it's got terminals, and a built-in fuse, and it's got an awesome capacity. So this is the 12-volt, 100 amp hour unit, and there is also a 24-volt version, which I'll show you in a minute. It's a little bit heavier, but first things up, that for a 100 amp hour battery is just awesome. It's really a game changer when it comes to a lightweight transportability. Now, I want to talk about some of the features of this battery. Some of the specs are written straight on it, but first up, I reckon this is one of the first lithium-ion batteries for the transportable market that I've seen that's really kind of got an eco-friendly approach. Now, one of the challenges with owning a battery is things go wrong sometimes. And, there's discrete electronics inside this unit. That's BMS, a battery management system, and there's some lithium-ion cells. The thing that's most likely going to fail is actually the BMS. And the BMS is this little top unit here with the metal heatsink on top. And it's a piece of electronics that, when I say most likely to fail, we're not looking forward to that. But if there was something to happen, it's going to be electronics, unless you've really abused the battery. To get this serviced or replaced under warranty, you can't ship a used lithium-ion battery back. It can't go by normal transport because it's no longer covered by the transport safety requirements for lithium-ion. But the clever people at Discover have come up with an idea, and I really like it. It's actually to have a removable lid. Now, this is the lid here. See, there's just some screws. We unscrewed the lid. Oops, that's the cover. And inside here is the BMS. Now, that BMS is a serviceable part, basically field serviceable by the owner. This could be shipped to them. They can swap out the BMS, put a fresh one on, and chances are their battery will be back in action. The other thing I really like about this unit is it's got a built-in overcurrent protection fuse. Now, you don't want to rely on this. You've got to have cable protection size to your cables that are leaving the battery system. But from a bare battery point of view, if something were to go wrong and you were to short circuit these terminals, even though it's only 12 volts, it'll be hundreds of amps until that overcurrent protection kicks in. And that's what this fuse is for, really just a final safety mechanism for the protection inside the unit. So I really like that. It's a serviceable fuse built into the unit. The form factor too, this is a DIN form factor. I think it's called DIN H6, so popular in European vehicles, but actually it's a bit smaller than your standard larger car battery, which might look more like something like this. Now, that's also a 12-volt battery, but this one actually is a lead-acid battery. Now, it's an AGM. It's empty because it's a dummy, but this is a real one. So it's a little bit heavier. If this was full, it would be like 28, I think, kilos, and this is about half that weight. So, the form factor is slightly more compact, as you can see, than a standard lead-acid AGM battery. One thing I want to point out is you may see branding lithium drop-in replacement for lead-acid. Just be really cautious about that because physically you might be able to drop into the holder, but the whole electronics that charge an AGM battery have got different settings to that for lithium. So a lithium battery has a different charge current, maximum charge current and voltage, but also the device that's charging it, in the case of a vehicle, the alternator, may actually not be designed for lithium straight out of the box. You may need to add something like a DC-DC converter or a regulated alternator that can limit the charge current, because these things really can suck a lot of current. This will suck 100 amps, and that'll be at idle when you're at the traffic lights. And so your alternator with a fan barely turning is trying to pump out 100 amps. It's going to get really hot. It's going to start smoking. So you need to be able to limit that current, and also the maximum voltage for an AGM will be different. I mean, this might want to go to, I don't know, 4.6 or so. This only wants to go to 4.2. That extra 0.4 of a volt actually is significant. And so you may find that your lithium battery is going into protection mode from over voltage and shutting down because you're trying to charge it to too high a voltage. So there's a few caveats when doing a swap with an AGM for a lithium ion battery. The lithium ion battery, I'll bring up a bigger one here, comes in different sizes from Lithium Blue. We've got that was a 12 volt one. And this is also 12 volt, but it's 200 amp hours. Whoa, 200 amp hours in this package. I mean, that's amazing. I should point out, amp hours and amp hours, if I was to compare lead acid, so here's a lead acid battery, right? And it's rated on the front here at 110 amp hours. Now 110 amp hours is its notional 100% capacity, but of course you can't actually use all that in lead acid. For a decent cycle life out of a lead acid battery, approximately 50% maximum depth of discharge. So really the usable capacity of this is more like 55 amp hours, whereas the usable capacity of this is 200 amp hours. So it's really 4 times more energy storage than this. Pretty impressive, eh? The other thing I like about the Discover battery is it's been designed from the ground up, actually as a lithium-ion battery that's in a form factor suitable for RVs and caravans. It's not just a generic replacement. Now, there are generic replacements. That's another lithium-ion battery from another brand, but it basically just comes with bare terminals on the top. I've had to put in a overcurrent protection fuse, and a socket outlet that it's going to use to run a cigarette lighter socket outlet, and I had to manufacture my own protection for the terminals because the terminals were exposed here and here, and so all of that is actually built in to this battery. So if I turn this over so you can see it a bit better. Boy, this is heavy. There we go. Because the 200 amp hour one is twice the weight of the 100 amp hour one. And there you go. You can see the terminals, and in this case, the terminals on the generic lithium. So it makes a big difference having these covers, which means that in transport or in storage, you've got built-in short circuit protection on the battery itself. A very sturdy and foldable handle, and when the handle's folded in, the top is flush, so there's nothing, if you put something across the top of here, it's not going to press on the terminals. That also means that you've got a more compact battery. Now, if you want to get a maximum amount of storage inside, your caravan, like underneath the seats or something, this battery will store a lot of energy in that very small, compact space. But there's a few other things that are worth considering. Now, if you've got a lithium-ion battery that's got a different voltage that's not necessarily suitable for the alternator that you're using, I said you could use a regulated alternator, but equally you could use a DC-DC converter. And something like this, this is a Victron product. It's called the Orion. This is actually a 48 to 12 volt, but you can get ones which will be 12 volt, 24 volt, 12 volt, etc. This can regulate the voltage going from an alternator, for instance, to the battery itself. Now, that's a very nice solution. These batteries also come in 24 volt variants. Now, 24 volts is not that useful for most RVs because all your lights and circuits run on 12 volts, but that's where using one of these can come in handy. You could actually, for instance, install a 24 volt version of this. Your cable sizes go down, your overcurrent protection requirements go down, your losses across those cables go down. Basically, you halve everything in terms of losses with the same size cable, and then use a DC-DC converter for those 12 volt fittings, the lights, etc. that are dedicated to 12 volts. But it gives the advantage of being able to run a more powerful inverter. Now, I've got one behind me here. So this is a Victron 24 volt, I think it is. Yep, 24 volt, 3000 VA inverter. So this is their suitable for a 24 volt battery. So if I had the 24 volt version of this, I could run this 3000 VA inverter in my RV or caravan, and I could use a DC-DC converter like this to drop down to 12 volts for all those appliances that only run on 12 volts. Kind of nice color match too, isn't it? Yeah, so this is Discover's batteries, and of course these are Victron products as well. A couple of things I wanted to talk about when it comes to these batteries is things like safety. Now, a lead-acid battery, even a so-called sealed lead-acid battery, will vent a small amount of hydrogen. It's unavoidable. It vents a small amount of hydrogen under full charge, and therefore you have to have some ventilation for the enclosure. You don't want to build up hydrogen inside that enclosure. Lithium-ion batteries don't vent explosive gases. They still need a little bit of thermal ventilation, because the heat sinks on the top here will get hot under full charge. So you might be running 100 amps of charge current or into one of these. Well, actually 50 amps is probably nicer, I think it says. And it will start to get a bit warm, so you need a little bit of passive cooling. So you could put this in an insulated compartment on the sides and bottom, which is a great idea if you're in a very cold or hot environment. But just leave the top exposed, so the heat sink, which you might be able to see here, is actually metal. This is the heat sink here, is going to get a little bit warm, so it needs ventilation. Yeah, so I said that we need to consider lithium batteries when we're swapping from lead acid. So not only you are going to consider things like the alternator on your vehicle that's charging it, but any other charging source. If it's solar, your solar charge controller would need to be adjusted to suit. And if you've got a shore power with a battery charger, it needed to be adjusted to suit lithium. So just beware, it's not truly a drop-in replacement. You do need to make some modifications to the charging sources of your system. Another point I'd like to make is, even though this is a battery and it's like, it sounds pretty ferocious, 100 amp hour 12 volt or 200 amp hour 12 volt, they're not designed as starter batteries. They're designed as house batteries or auxiliary batteries. They don't have the cranking amps that you would expect from, say, a lead acid battery for starting your vehicle. So these are really designed as house or auxiliary batteries. There is limits to when you can charge one of these units. Now, the rating is for charging 0 degrees to 55 degrees Celsius. At the high end, that's pretty hot. If this is inside a vehicle, you're unlikely to want to be in there if it's 55 degrees. So that's probably not the problem, but low temperature. At 0 degrees, these won't accept charge. It's because lithium-ion batteries become unsafe to charge at very cold temperatures. How do you avoid that? Well, actually, if you're using the battery, it keeps itself warm, because charge and discharge, there'll be some self-heating. Not much, but enough to keep it, above 0 probably. But you could also put it in an insulated compartment, so it's protected from the environment. And if it's a really extreme setting, like you might be in the snow somewhere, you can put a warmer. So I've got some reptile warmers that you can put underneath the unit, and they only draw about 20 watts, I think, and you can turn it on just to warm the battery so that it can accept charge. That might be first thing in the morning. You might just use a little bit of the battery's energy to warm it up, so when the sun comes out, you can charge it. The protection is built into these in terms of over voltage, under voltage, over temperature, under temperature, over current. All those things are built in, but you don't want to rely on them as your first level of protection. For instance, with the 12 volt lithiums, you really don't want to go below 12 volt. That's the cutout voltage on the BMS. So I'd be setting my inverter, for instance, to a shutdown of 12.1 volts. So you're not bottoming out your battery every time, and it may even go into protection mode if you don't charge it. Protection mode is where a battery basically isolates itself for a period of time or waits for an external charge. The Installation standards for caravans in New Zealand and Australia is covered by AS/NZS 3001 for those in those two countries. There is a battery standard AS/NZS 5139, but it doesn't apply to relocatable vehicles such as motorhomes, caravans, RVs. So in terms of what standards apply, caravan standard, so-called caravan standard 3001. But if you're installing these as a fixed installation for some reason, then you need to consider AS/NZS 5139. Another thing about these, and I'm looking for my phone, here it is that there's a app, and you can monitor these directly with a Bluetooth app. Now that's pretty cool. So it's called Lithium Blue. You can get it from the App Store or Google Play, and you can directly communicate. I'm just actually connecting to both of these batteries. Here we go, and checking out its performance. So the app itself is a great way of monitoring things like state of health, state of charge, and other conditions of the battery. But even more importantly is that this can be a diagnostic tool. If you have a problem with your Lithium Blue battery, you can download, or better still actually, email a report to yourself or to your supplier, a diagnostic report straight from the app. So you just have to be within Bluetooth range, so that's partly in the name, Lithium Blue. If you're in Bluetooth range of the battery itself, then the app will talk directly to the battery and allow you to download a status report that you can send off for diagnostic purposes. So that's really cool. The case itself is V0 rated, meaning non-flammable, and the whole unit is IP67. So, you know, it can accept dousing with water, but it's not submersible. So don't go using it for undersea diving, but it is well protected environmentally from direct impact of water. Now that means it can go in places that are a bit harsh, but I'd still be treating it a bit kinder than that, because you've got electrical connections to it and other equipment, so you probably don't want to put it where it's going to get wet. The electronics inside this use a system known as top balancing. Now what that means is that the lithium ion cells, and I should grab one actually, I've got one back here. So this is a 100 amp hour, 3.2 volt lithium ferrophosphate cell. Put some tape on there just to be safe. And inside this battery will be 4 of these internally connected in series. Now, because there's 4 of these in the 12 volt units, so I think the 24 volt ones use cylindrical cells, slightly different size, they need to be balanced so that they're all operating at the same voltage. And that's done with the BMS. So this clever little piece of kit is monitoring each of these battery modules and cells and giving them a little top-up charge to bring them all to the same voltage. Now that's done at the end of a charging profile. So when a battery system is charged to say above 90%, maybe even 95%, then that balancing starts to occur. So therefore it's kind of important that occasionally, I'm not sure what the interval is, I'll probably put it in the description, that you need to go to the maximum voltage of the battery for a period of time so that balancing does occur. So that's just a little a quality mark in terms of making sure the battery has the maximum longevity. So just for your information, these are called prismatic cells and cylindrical cells, which I haven't got one handy around, and they're both the same chemistry, lithium iron phosphate. So there you go. That's Lithium Blue from Discover Energy. Really like these as a recreational vehicle battery, and I'll be taking them on my next camping trip. Thanks for watching.